Yes, I received it yesterday on my email.
Yes. Yeah, everyone can see my screen.
Yeah.
Yes. So yesterday we have discussed that Shunek and VCD, right? Today we are going to see reducer. So the purpose of reducer, why we are using, after distributing our CFM. So this is our main duct. From main duct we are connected to 4 branch ducts, right? So this is my main duct. For main duct we connected 4 branch ducts. So 4 branch duct, let's say that we'll consider this CFM only. 600 plus 1200, 1800. 1800 plus 1000, 2800. So 2800 plus 400, 3200. Right?
Engineer, yes.
Yeah.
Could you please ask the rest of the person who attend with us to mute the mic? There is a lot of there is a lot of noise. Please, everybody, close the mic.
Yeah, I'm closing
Unless
everyone.
unless you have
So I closed everyone mic. Yes. Now here, this is our main deck. For main deck, we are having 600 one branch deck, 1200 one more branch, 400 one more branch, and 1000 one more branch deck. So total, if I add 600, 1200, 1000, and 400, I'm getting equipment capacity will be so 3200. So here I'm inputting. So equipment capacity I'm getting 3200. After distributing my 600 CFM here, so 3200 is coming here. 600 I am going to distribute. After 600 I am distributing. After this branch duct, my duct is going to carry 2600. So it means just I am opening my calculator. So total 3200 CFM I am having. So first this branch I am having this 600 minus 600. So 2600. From here we are going to carry 2600. For 3200, T enter text 3200 CFM. We are maintaining length and width different sizes, as well as 3200. After this branch, after distributing our CFM, it's going to become 2600. Again 2600, 400 is going to enter here. 2600 minus 400. So it will come 2200. 2200, it's going to distribute here 1200. 2200 minus 1200. Finally we are going to get 1000 CFM. You are getting? So these things and all I'll move, then you will get one idea. So 3000 CFM is coming from my equipment. 3200 CFM, it's going to distribute 600 CFM. After that, from yellow point onwards, sorry, white point onwards, 3200 minus 600, we are going to get 2600 CFM. Again, this 2600 we are going to carry up to here. This 2600 minus 400, we are going to get 2200 CFM. right? Again, this 2200 CFM, it's this duct is carrying 1200. So finally, we are going to find 1000 CFM. This 1000 CFM, this duct is going to carry. Now, for 3200, we are maintaining some size of duct with height. So here always we are going to calculate width and height only, not length. Length is depending upon our layout. Length is doesn't matter. Width and height only we are going to calculate for CFM. Let's say that basic example for 3200 CFM, I am having size of duct. Maybe think that. So here only I'll open macro calculator. So this one later I'll discuss with you people how you have to calculate duct size under 3200 CFM. I am inputting. My head loss will be 0.08, 350, 850. So for 3200 CFM, I am maintaining duct height with duct width will be 850, height will be, sorry, duct width will be 850, height will be 350. Same CO enter copy, this text I am maintaining here. For 1000 CFM, I am opening my macro duct. This is called macro duct sizer. This one we will discuss later. How we have to find our duct size and all. So 350, 350. See here. For 3200 I am getting 850 into 350. 1000 I am getting 350 into 350. Is it necessary to maintain 850 till end of my duct from this point to this point? Is it necessary? We are going to reduce our CFM. If we are going to reduce our CFM, we have to reduce our duct size also. Otherwise, unnecessarily material quantity will increase. So our project costs also will increase. And we can't maintain that much pressure and efficiency we can't maintain. If you are having how much CFM you are having, as per CFM we are going to calculate our duct size. You are having less CFM and you are having more duct sizes, what is the use? Here, so for that what we are going to do, we are going to do reducers. It means we are going to reduce our duct size. Reducer is nothing but we are going to reduce our duct size. So in this reducer, we have two types of reducer. We have two types of reducer. One is concentric reducer. One is concentric reducer. And one more is eccentric reducer. So here I'll maintain. Yes. So this is types of reducer. Second one is eccentric reducer. Eccentric reducer. So two types of reducer we are having, concentric and eccentric. So here I'll text. So concentric and eccentric, how it will look? Depending upon shape, we are going to call concentric and eccentric. So concentric means Both side we are going to reduce our duct size. So let's say that this is our duct and this is also our duct. So this is our reducer. This is concentric reducer. So this symbol indicate that till duct is there, not only duct, so till length is there. So this is concentric. Same eccentric also will look. This is my eccentric. So the difference between concentric and eccentric, if it is concentric both side, top and bottom, we are going to reduce our duct. Eccentric means one side only we are going to reduce. So this reducer wherever we are going to use. In ducting, we can use either concentric or eccentric. But some rare cases, whenever we are preparing our ducting near the wall, that time for aesthetic look, we are going to use eccentric. And compared to concentric to eccentric reducer we can make easily. Clear? The difference between concentric and eccentric will be concentric will reduce duct top and bottom both side, but eccentric only one side, either top or bottom. Don't think that only top or bottom. So maybe I'll show this one how it look one more also. Right. So if you see here, this is my reducers. So let me give you small drawing only, then you won't get any confusion. I think now you people can see easily. This is my concentric and eccentric. So this formula of concentric and eccentric, whatever W2 minus, sorry, W1 minus W2 into 4. So W1 will be big duct width So W1 will be big duct width, W2 will be small duct width. Big duct width minus small duct width into 4, and whatever the dimension we are getting, that is length from here to here. This is called reducer length. It should be 400 to 750. If you are getting below 400, we have to select 400. If you are getting above 750, we have to select 750. So I'll take you examples here. So a small basics example I'm going to take here. Here same I'm going to take, and reducer we are preparing only for width, not for height. Clear? And in between reducer to reducer, at least you should maintain 1000 cfm variance. At least you should maintain 1000 cfm variance. So here 3200 I am having, here I am having 2600, so 600 cfm only variance I am having. Here if I take 600 plus 400, I am having 1000 cfm. So ex enter extend. Now for 3200 we are distributing here 600, after we are getting 2600, 2600 again we are distributing 400, finally we are getting here 2200. Just opening my macro duct sizer, unit change into IPS, 2200 unit change into matrix. So 600 by 350 I am getting here. Here we are getting 600 by 350. So 850 will be W1, 600 will be W2. The formula will be W2 minus W1. It means 850 minus 600. How much we are getting difference? 250. 250 into 4. What is the length of reducer I am getting? 1000 mm. So 1000 mm, is it possible? 1000 mm not possible. So what we have to take, maximum value will be 750. And whenever you are preparing, either it is reducer, elbow, branch duct, whatever, after ending your duct, at least you should maintain 1 feet distance from here to here. I am taking one line, so this is I am maintaining 1 feet distance. M enter move 300 mm. At least you should maintain a gap here 300 mm. At least you can maintain 600 mm. It means 2 feet. In between reducer to elbow, elbow to branch duct, whatever the things, at least you need to maintain 1 feet. Here 850 minus 600, 250 I'm getting, 250 into 4000 I'm getting. So 1000 I can't take. This one I'm going to take as a 750. Selecting this one, O enter, offset 750 enter. Then so DLI, just I'm showing you from here to here I'm getting 750 mm. And oh, this is 450 only. Okay. So here I am having duct will be 850, and after by reducer I go on to reducer my duct height and width from 850 to 600. So this is my reference line, right? I'm going to change my color for reference. I'll enter line from this point to 600 mm, because this duct's height width will be 600. 600. After that, this white line I'm deleting. I'll enter line from this point to this point. I'm going to connect whatever additional line I'm having. That's I'm going to trim. This one I'm moving from this place to this place. Understood, guys? How I prepare reducer? Understood or not?
Sir, I have a question.
Yes.
How about tight places, small places? Does it 400 mm apply, or can I make it reduce less?
See,
What is the minimum length?
reducer should be 400 to 750. If you don't have space, you can maintain only 400.
Okay. How about if I need less, like 200 mm,
No, it's not
250?
possible.
Not possible. Okay.
Sure, you have
It's
to
not
maintain.
possible on real life, or it's not possible because this is the rules of ASHRAE.
Yes, Ashay only. See, that reducer, why I'll show you. Let's say that here you are maintaining your reducer. Just basic
Okay.
concept. Your air is coming from equipment to straight. Always, it won't take any direction. Clear? So usually as comfort, when we are driving the vehicle, we won't like to take turnings and all. We used to go straight manner only, right? The same way, air also going straight manner. Here air is touching the reducer. Total 3200 air is coming here without entering into my branch duct. Here it's touching. Here there is no space to go 3200 CFM, because we designed duct for 2200. Then remaining CFM, it will try to escape from this duct and this duct. Getting?
Yes. Okay.
And this distance, if you are not going to maintain at least 400, what will happen? Air will come, it will touch our duct here. Whenever our air is touching our duct, some sound will happen inside the duct. Sound and vibration. To avoid that things, as per ASTRA standard, we are maintaining reducer length will be 400 mm. At least minimum will be 400, maximum will be 750.
We can use
But
straight reducer.
yeah, we can use it. So here we have done our eccentric reducer, and we can go for concentric reducer also. So concentric reducer,
Hello.
I'll show you here. Yeah, tell
You
me.
buy that 400 and 750 is there, no? We
Yes,
need to use either 450, 400 or 750, or between that
in
value,
between
between
what,
this 400 and...
if let's say that my main duct width will be 800.
Okay.
After the 800, I'm getting 700 duct.
Okay.
I'm getting ratio will be 100 mm. 100 into 4,
Yes. 400.
400. So 400 I can maintain. Same concept,
Hmm.
if I am having 850 duct, opposite duct will be 700. I'm getting 150. 150 into 4,
Yes.
600,
600.
right? So I can use 600 duct.
Hmm.
So reducer. So
Length of
Do
the
you
reducer
have
is
length,
a chart
600.
of duct size, standard duct size chart you have?
standard duct.
Duct size.
Yeah, tell me standard duct size.
Do you have a chart of standard duct
No,
size?
here we are having one software. This is called Macware duct sizer.
Okay.
So chart means manually you have to select.
Okay.
But here in the software, if you input your CFM, automatically you will get duct sizes.
Okay.
There you can select your sizes.
Okay. Okay.
Clear?
Yes.
Now I'll take here some duct sizes only. As per that, some rough calculation I'll show you. So here I am having one duct. Clear? So offset will be 1000 mm, 1000 by 2. So whenever you are taking offset, 1000 by 2 if I took, 1000 by 2 means top side I'll get 500, bottom side I'll get 500 mm. Now if you can see here, how much I'm getting size? 1000 mm. So this center will be reference point line. This is for our reference line. Now here I'll give you text, T enter text. Maybe here I am having 1000 width, 1000 width. After here my width will be 950. This for a calculation, rough calculation. And here it's became 700. After 700 it's became 450. So 450 finally it's became 200. So this width and all you are going to get from your Macway duct sizer. So as per CFM, we have reduced our duct. Now we will go for our ducting size. So L enter line. So I'll change my color. L enter line. So this 1000 mm duct you are going to end here. So maybe this is my equipment. Clear? This 1000 mm duct I'm going to close here. And after that I have to start 950 duct. 950 duct means so 1000 mm minus 950 mm. What is I'm getting value? 50. 50 into 4. I'm getting 200. 200, is it possible to take my reducer length? Is it possible? Can anyone?
No, no, no.
No. So how I have to take minimum? How much I have to take?
400.
400.
400.
Now this one I'm making O enter offset 400 mm. Right. Again I'm taking one more line for reference. L enter line. I'm taking from here to here. How much I have to take? This line? 950.
950.
950 enter. So this magenta line I'm going to delete. E enter erase. Then L enter line. From this line end to this line end. This I'm going to trim. TR double enter trim. M enter move. This one I'm going to move from this point to this point. After that I'm going to trim my reference line. So this center line will be always take for reference only. This one I am going to move in center. Now we can check that this one I am having 1000 and this I am having 950, right?
Yes.
Again after 950 here I have to make reducer for 950 to 700. So 950 minus 700, what is I am getting?
250.
250. 250 into 4. What is the
1000.
reducer length I am getting?
1000.
1000.
1000.
So 1000, is it possible to take?
No.
Now how
No.
much I have to take?
750.
750.
750. So this one I am taking, Y enter half set, 750 enter. So here I have made bottom. Now I am going to make here top. Again I am changing color, L enter line. From this point to I am making 700 line. After that this line I am going to erase, L enter line. From this point to this point I am taking a line. So after that this I have to divide for TR double enter trim. I am trimming here. This one M enter move from this point to this point. Again
No.
TR enter trim. This reference point line we are moving as per our convenience. Once if you became expert in AutoCAD, you don't want any reference lines. Now we can check DLI. What is the length I'm getting?
700.
700. So here I'm changing color for your reference. Actually, we won't change any colors. This is for your reference only. So here eccentric reducer we have done below and top. Now we are going for concentric reducer. After 700 we are having 450. L enter line I'm going to take here. 700 minus 450, what we will get? 700 minus 450. 250. 250 into 4. 1000. 1000 means how much I have to take?
750.
750, right. O enter offset 750. Now to prepare this reducer, one line only I have trimmed, but here two lines I have to trim. TR double enter trim. This one I am trimming, as well as this one I am trimming. Then this is 450, right? 450
Yes.
means this also I am deleting. This also I am deleting. Total I am deleting. Reference line selecting this one. O enter offset 450 by 2. Enter. Top side and bottom side. L enter line from this point to this point and this point. After that extra line whatever I am having, this one I am deleting. Now understood concentric and eccentric how we prepared? Again I'll show you
Got it.
here. So after 450, same this line I am going to copy. CY enter copy. 450 minus 200, how much we'll get? 450 minus 200, 250 I am getting. 250 means 1000. We have to take again 750. O enter offset 750. So this line I am going to delete. O enter offset 200 by 2. L enter line from this point to this point and this point, this point. Guys, our class is going to end. I'm going to send new link.
Okay.